It's about a minute past, and I thought we probably just should get started. Good afternoon, and welcome to the University of New York School of Professional Studies webinar on cloud security. The webinar topic today is cloud security, which is a very broad topic, and it's really hard to do it justice in 1 hour. In the talk, I'll provide an overview with a focus on infrastructure as a service, so-called IaaS. The service model where clients have the most flexibility and the ownership of security. And as I mentioned before, if you have any questions, please put it into the questions window and we can move on from there. So in order to provide some background to those of you who haven't really spent time looking at to use an analogy of what a cloud is. So the first thing I wanted to talk about was, what is the difference between a product and a service? At its most basic, a product is something you own and a service is something that you use. For example, you own a car, you own a house, you use a taxi service, you use electricity, you use the phone network, etc. It's a different paradigm. Obviously, in order to if you have a product, then you can use it, but there's a fundamental distinction between them. So to kind of explain that, I wanted to use the analogy of a car as it's owned and a service which is just getting A to B. So if you look at the leftmost column, you'll see that if you own the car, you're responsible for an awful lot of prerequisites or components of that car to get it moving. The physical car, the financing of it, the depreciation, all of those. But not just that, it's worth knowing that you need to have a license. You need to be able to drive the car, and you need to pay for individual usage. Now, the next stage is, if you just want to lease it, then effectively you're outsourcing the servicing, the renewables, all of that, a lot of the other stuff. So I should say you're outsourcing the car, the finance, and the depreciation, but you're actually keeping the servicing, renewables, insurance, etc. Then if you're hiring a car on a day-to-day basis, you're actually outsourcing an awful lot more, so that the car, the depreciation, the finance, all of that is really the responsibility of the rental car company, and it's really up to you just for the pay for the fuel, the road tolls, but at the end of the day, you need to have a license to actually drive it. And then you have the last scenario, which is a true service. You need to get from A to B. You call your taxi up or you call Uber up, they come to your door, and they will actually drive you. So we've gone from a product to a service, and essentially that's what the difference is between them. Now, in terms of a cloud, you'll hear an awful lot about as a service. The whole point of the cloud is to turn everything that we use within IT into a service, whether that's security, identity management, the way the data is stored, the way it's used, computing aspects of it, all of that is turned into a service. Now, if you look at the bottom, there's a number of cars, and I deliberately chose these. The one on the left is a Honda Odyssey, and believe it or not, that is actually the car I have. I have 3 kids. They go to soccer, swimming, an awful lot of activities, and I ended up purchasing my car, and it's a 5 to 8 year investment. Now, I purchased this, and I purchased excess capacity for it. I mean, potentially I could take an additional 5 kids with me to soccer matches. And there's an awful lot of spare capacity there. But at the end of the day, I'm stuck with the car I have in my garage. I can't make it smaller or bigger. I can't scale it. It is what it is. It's an investment that I'm stuck with. Now, occasionally, what I'd love to do what I'd like to do is actually get rid of that as my kids get older and move into a potentially an SUV. But, you know, I've purchased it, I'm stuck with it until actually I replace it. Occasionally when we go traveling, I really don't want to have a gas-guzzling, minivan. I'd like to have perhaps a convertible or something that uses far less mileage, but I'm kind of stuck with it. And then these are some of the issues that we have with investing in IT infrastructure. Once you've purchased it, you have it, and how you use it is dictated by what you have. So it's the old analogy of when you have a hammer, everything looks like a nail. If you could change the type of infrastructure you have or what you can use, then I think you have far more flexibility. But when you invest in it and pay for it up front, you're stuck with what you have to a large extent. And this is a quick analogy to kind of explain some of the concepts. So to get down into IT infrastructure, let's talk about the next slide, which is how that relates to IT technology. So on the far left is the traditional dedicated IT, which is the on-premises data center. You have the entire stack at your data center. And what you see in green is what the organization is responsible for. The orange is what's the shared responsibility. So for example, in the leftmost column, which is the on-site dedicated IT, the yellow is where, for example, the network is shared. So, you know, internally, it's run by the organization, but externally, when you interface with the internet and the telecoms, that's shared responsibility. And then the red is what the service provider provides. So as we go up the cloud stack, you could see that you have what's called a public infrastructure as a service, which is the middle column there, public IaaS. What that is that the network, the storage, and the servers are provided by the cloud vendor, and the data and the applications are controlled and run by the cloud user. And the abstraction layer is the virtual memory, the hypervisor layer, which we'll talk about in a couple more slides. Now the next one is the public platform as a service, and what that is that additional layer of the stack is actually provided, or the shared control by the cloud service provider. So in this case, typically a platform as a service is a set of APIs that you'd write to. You wouldn't have access directly to the operating system of the virtual server. You would be actually using a set of APIs like Google App Engine or Heroku, something like that. And then the last one, which is at its most basic, is the public software as a service, things like LinkedIn, Salesforce, etc., where the only thing that you look after is the data, and everything, including the application, is provided by the cloud provider. Now, in terms of the IaaS, the PaaS, and also the SaaS service offerings, they can be provided publicly by a cloud provider such as Amazon or Microsoft, etc., and that's the public cloud. Sometimes, for example, in very large organizations where the inefficiencies or the excess utilization can be shared across multiple divisions, then it makes a lot of sense to have a private cloud. Then we have another variant, I should say, which is the hybrid cloud, where you have a private cloud together with a public cloud. And typically this is where the very large organization has a private cloud, and where additional or capacity or peak infrastructure is then offloaded to the public cloud, which is very common. Something you probably don't hear about very often is the community cloud, which is numerous organizations banding together to essentially create a cloud, typically private, although it can be hybrid, that will meet the requirements of those. It can be you know, typically for example, credit card companies, things like that, which are have very common requirements, and where it makes sense to actually share that infrastructure. Okay. Let's talk about the characteristics of a cloud. These are the core characteristics. So the first one is it's on-demand self-service. As soon as you need it, you can provision it. Now that can be done through a console, or more likely it's done through an API that the vendor provides. So as soon as you need it, you can request it and it's available. The second thing is ubiquitous network access. You don't need a dedicated network or a telco line to the provider. You can get access anywhere in the world, which ensures full redundancy. Next one we have is resource pooling, which is the excess capacity from the cloud provider is pooled, and it looks like an unlimited, it can seem like an unlimited supply of resources. However, to provide pooling, it's worth noting that you have to have standardization. Customization is very restricted, otherwise that defeats the purpose of pooling. Nevertheless, you have multiple types of resources that you can order, but they're all standardized in a specific way. The fourth one is rapid elasticity. What this really means is the old, if you remember economics, the buy and the demand and supply elasticity. What we're basically saying there is that as soon as the demand is there, the supply is immediately available. You need one server, you need 100, you need 1,000. They can be immediately provisioned. So going back to the analogy of the car, you know, if I've got my minivan, if I want a truck to do haulage, I could just basically call it up. If I want a bus to take the entire soccer team, I can. Immediately I can scale up. If I need 2 taxis, 100, not a problem. When I own the resources, I'm stuck with what I have. Whereas if I use a service, I can specify what I want to use. And the last one, which seems pretty self-evident, but it's important to note, is you pay for what you use. This is like electricity. You plug your device into the wall, you use the electricity. When you unplug it, you stop paying for it. Essentially, that's the model that we have. So just to round out the definition, there's a couple of definitions. I think the official one is the National Institute of Standards and Technology, the NIST definition, which is called the 534 model. Essentially, we have 5 essential characteristics that we spoke about, which is on-demand self-service, ubiquitous network access, transparency, elasticity, and consumption-based charging. You have 3 delivery models, which is SaaS, PaaS, and IaaS. And then you have 4 deployment models, which is private, public, hybrid, and community that we discussed. It's worth noting that there is probably a better standard, which is the 532 principle of cloud computing. Essentially, it's the same one, but it really recognizes that hybrid and community deployment are really just variants of private and public. I mean, I think you're mixing apples and oranges when you start throwing in hybrid and community with public and private. It just makes a lot more sense just to say private and public and move forward from that. So I wanted to spend a few minutes to actually go through the definition of what a cloud is for those of you who haven't gotten into it, and if you have any questions, please let me know. Okay. Next question is virtualization. So the cloud providers obfuscate, or I should say segregate the usage of the cloud by setting up virtualization between the different systems. Essentially, everybody has an environment which seems unique and completely separate from everybody else. So going back to the car analogy, it's like you get rid of your car and you have a service to take you from A to B, but essentially you're all on the bus, but you're segregated so that you don't know anybody else there. Completely separate environment, and you're completely oblivious to anybody that's next to you. Now, the point of virtualization is to separate the physical from the virtual hardware. In theory, it's not possible for you to figure out whether you are on physical or virtual hardware. There are tricks in doing that in terms of figuring out what API calls the hypervisor has, but if the hypervisor is set up correctly, it's impossible for you to know. The hypervisor is the abstraction layer. It's what virtualizes and abstracts the hardware from the software. Now, the hypervisors or the abstraction layer comes in really two forms. The first one is what runs on the firmware, and it runs straight on the silicon. And then the second type is the thing that runs, or the variant that runs on top of an operating system. You may be using the one that runs on typically on an operating system. There's actually very good virtual memory monitors that run out that are out there. Very good version is Oracle VirtualBox. It's free. I suggest you guys download it. I have a Macintosh at home and I want to run PC applications. I run Oracle VirtualBox on top of my Macintosh. Absolutely not an issue. Everything runs beautifully well. So it's as though I was running a PC, and if I actually do a full screen, I have a PC running on top of my Mac. So in terms of the hypervisors, the ones that are typically run by the cloud providers are the ones which are running straight onto silicon, which completely isolate the applications. And the benefit, another benefit that comes out of this for cloud users is that you can run very old OSs and support old versions, even though that you may not be possible in your development center. So you can test scenarios with the latest OS, previous OS, etc. So it's very easy to figure out how to run. And it's very cost effective, as I mentioned. Okay. Next slide. Wanted to provide a quick overview of who's out there in terms of cloud vendors. On the right-hand side, what you have here is a Gartner 4-quadrant. This is one of their typical 4-quadrant magic boxes, I think they call them. As you can see, in terms of the leaders and visionaries, you have Amazon Web Services, and frankly, daylight until you get number 2 to Microsoft, and then you get to Google, and then the rest. Essentially, Amazon Web Services, AWS, was the first, and it has a considerable amount of steam, has critical mass for this, because at the end of the day, cloud service providers is a scale business, and it's a very high barrier to entry. So essentially, the first ones are the ones who have a lot of the market share. So as I mentioned, Amazon Web Services is the market leader. Typically, it's the safe bet. They built it there. They built it first, and they essentially, it's the gold standard in the industry. Microsoft is been catching up to a large extent to Amazon Web Services, but Microsoft, just like IBM and some of the others, are really trying to extend their current deployed customer base into the cloud. Typically what you find is that they will take their existing contracts and add a cloud addendum and make it easy to transfer some of the existing services to the cloud. Typically true with IBM, who are extending their existing business over to a new acquisition that they had for the cloud, which is the soft layer IS provider. But as you can see, Amazon is essentially the market leader. Microsoft has done some very nice things, particularly around Active Directory, extending the existing servers over to the cloud. And then you have Google, which frankly the biggest issue they have is they don't have a good global presence, surprisingly. They have a very good presence in the US, but their data centers in Asia in particular, and to some extent Europe, are really lagging. So if you're running a global business on the cloud, Google is probably not there yet. They plan to extend the network of data centers by the end of 2017, and the pricing is very aggressive to really reflect where that stands. Okay. So what are the benefits of migrating to the cloud? I guess the first one is lower cost. I mean, that's the one everyone speaks about. That essentially comes from inefficiency. The data center on-site server utilization is very low typically. We build data centers so that they have spare capacity. We build in peak usage, and the power consumption of data centers is very high compared to the efficiency. An anecdote I could probably share of a previous company I used to work for. What used to happen was that in order to improve data efficiency, the data center personnel would force application developers to run and share hosts. And they typically did that by looking at the load factor on the servers. Now the AD managers weren't dumb. They realized this. So what they ended up doing was that they set up processes to run and eat up the CPU so that they didn't have to share services, share hosts. And the reason they would do that is that because if you share hosts, what would happen is that you would have to coordinate what you did with those servers with the other applications. You couldn't just take it down. When you do upgrades, you had to coordinate the different components on the servers. So sharing is not something that people really want to do. And what ended up happening is because the application developer managers and the production implementations would eat up the CPU, that ran up the power consumption and made the data center even more efficient. And this was the days before virtualization data centers. But people will always try and figure out ways of maintaining their own environment, and which would result in inefficiencies. But lower cost is a major deliverable within cloud computing. Anywhere, depending on 30% to 70%, depending on if it's cloud computing, the type, and whether it's storage. Some fundamental savings there. Here are some statistics around that of some of the benefits, and I'll kind of go through them. One thing to note, security in the cloud is, in theory, a very good thing. If your organizations or some of the places that you are aware of are any reflection, sometimes it can take an awful lot of time to implement patches, to upgrade software, etc. On the cloud, because of standardization, every time you fire up an instance, it has been patched. You, in theory, have the latest version of software. It has the security enabled. So the standardization is a very good thing for promoting security, and in theory, the cloud security is as good as anything else. Another thing is reliability. You have a massive pool of redundant IT resources. Manageability. Takes an awful lot of effort to actively manage the resources out there. And by the same token, cloud management also takes up an awful lot of time, but it's easier to scale up and down, and I think the migration and the infrastructure upgrades is something that significantly saves time. Procurement cycle is frankly my pet peeve. It can take, in some organizations, quarters, months to procure servers. It can take a very long time. And that assumes that you have room in your data centers. Now, even when you do, if you're in highly unionized locales like New York, it can take up to 3 different people to install your server. One person to physically move it and put it into the rack, one person to plug in the electricity, and another person to plug in the network and set it up. So it's a slow cycle when you have to line up all these people, the data centers, rack space, and get the servers in. It can literally take months. Whereas with the cloud, it's a very quick time to market. The primary benefit of using the cloud, I believe, is from a business perspective and a competitive advantage. Migrating some or all of infrastructure to the cloud frees up a lot of resources, both management and financial resources, so the business can focus on its core competencies to where the business has a competitive advantage. More importantly, it makes the technology more responsive to the business. Projects that typically take quarters or months can be done in weeks. One good example that you can probably Google is the one about the New York Times archive of historical articles. They went to their on-premises data center personnel and asked for an estimate, which was like months to get the NAS service set up, to get the computing service set up, whereas they had a pilot up and running on the weekend, and that included migrating their entire archive over to the cloud. So in terms of responsiveness to the business, it just, there's no comparison. And really it turns IT from a cost center to much more of a cost, or should I say profit center, and a partner to the business. And the speed of business increases. If a business wants to get into a new market and try and see whether it works, it's easy to scale up. If a particular business is not, a particular market is not working out, like Asia or Europe, it needs to be reduced, that's okay, we scale down. So having sold the virtues or extolled the virtues of cloud computing, the thing I wanted to throw up was the Gartner slide about the hype cycle, that injects some realism into the cloud discussion. It's a powerful new enabling technology, but it's not the answer to every question. And really, the cloud, and particularly the security, is something that you need to think through very carefully. So the first one is cost. Now, everyone says get into the cloud because you're going to save a lot of money. Okay, great. So you've got a $4 million budget, you save 50%, now your budget is $2 million. What are you going to do for an encore? You've got a promotion, you've got a pat on the back, maybe you've got a bonus. Great, you reduced the budget by $2 million. What are you going to do for an encore? Are you going to reduce it again by $2 million, by 50% next year? So the point of that is that you can't use cost as a continual justification for the cloud. Yes, there is a big bang, and it's worth noting that under the GAAP standards, you can only book that once. It's not like you can book that saving every year forever. Once you actually book it, you turn a capital expenditure to an operational expenditure. Great. What's next? The other thing to note is that when you move to a vendor, like Amazon or Microsoft or whatever, they will work really hard to lock you in. They will give you features with the API, for example, the elasticity API. They will give you features for the services, the servers, the server types, perhaps customization. They will give you hypervisor features to lock you in. If you code to that, particularly with PaaS, the cost of getting out, moving to a new vendor may be prohibitive, and your leverage in terms of negotiation and cost really dries up. So it's very critical that the API that you use to access and manage the cloud is obfuscated, and you abstract them away so that you can, at an instant, move from Amazon to Microsoft, to Google, to whatever. So vendor lock-in is, I think, a key. Next thing is architecture. The existing architecture that you have, you just can't take that and move it to the cloud. There's unique challenges and benefits to the cloud, and that has to be reflected in how you actually migrate. And we'll talk about that and some of the tools that you can use, in particular CUNY and Army. That'll be in the next slide. Security is the next one. There's a couple of choices you have to make in terms of security. You can treat the cloud as an extension of the on-premises, or you can treat it as a separate trust environment. And then how the cloud is handled, we'll talk about some of the use cases in subsequent slides, but essentially security is something that needs to be very carefully thought through. Regulations. At the end of the deck, I've put in the appendix a list of all of the regulations that, the major ones I should say, which relate to the cloud. Two major ones to note. The PCI-DSS, which is essentially the card provider that has become the de facto standard in terms of security. The other one is the health insurance providers, the HIPAA regulations. They restrict what data you can put on the cloud in terms of privileged and confidential data, the PII data. So you have to be careful that what you put on the cloud, A, you have a license for the software, and B, you meet the federal and the state mandates around security and privacy. Then we have a couple of issues that really relate around the service level agreements and your relationship with the cloud provider. First of all, visibility. When you have an issue on on-site premises, you know where the problem occurred. You can do root cause analysis. You've got a single throat to choke to identify where the issues are. When you're dealing with a cloud provider, you are completely at their mercy. You may or may not get a root cause analysis. You may or may not get full information. Really, that all depends on your service level agreement. Now, the service level agreement is the next point. Specifies in terms of what rights you have if there's an outage, or what information you're provided. Typically, the SLAs in terms of outages are in the high 9s. Typically, it's 6 hours outage. Anything more than 6 hours outage per year, you can get clawback from the cloud providers. But that clawback is for what you provide, or what you pay for the service. It's not for the material or the business damage that you've received by that outage. So it's worth noting and very carefully going through the SLAs. In addition, as part of the SLA, you need to make sure that accessibility and latency and also peak usage and availability is all addressed. Because going back to the Uber model, think about what happens with Uber if it's a rainy day. The price of the compute power goes through the roof. If there's some sort of emergency, you're not going to get an Uber. So in terms of cloud computing, will you be able, will elasticity work when you need it? Will you be able to get it? What is the price that you're going to get? Now, one thing I won't have time to talk about on this slide deck is the spot pricing within Amazon and also some of the other vendors. Now you have standard pricing, but you also have spot pricing. If you choose to go spot pricing, you can, in theory, get much cheaper rates. But by the same token, if there's an unusual demand, your server may be taken away from you to be given to someone who's willing to pay more. These are some of the things you need to think about moving to the cloud. And lastly is, do you have the people who know what the cloud is, how to use it, etc.? Do you have the requisite level of knowledge? It's this is a time check. It's 1/2 the hour, and I'm talking a little bit fast, but I just want to make sure we cover everything. If you have any questions, please just jump in and let me know. We'll get on to the security in a slide or so, but I just want one last thing to finish off in terms of migrating to the cloud. If you go to the Amazon site and have a look at the migration recommendations, you'll see the step-by-step process. This is just copied from there. And it's worth noting that in order to migrate to the cloud, you have to go and carefully think through how you're going to do that. Think about the impact in terms of regulations, cost, ensuring that you're not locked into the vendor, that you migrate your applications, re-architect them properly, etc. So plan, proof of concept, execution, optimization is key. Security, we'll touch on that in future slides, but as I mentioned, in theory, the security should be as good as on-site data center security. The thing I want to talk about on this slide in particular is the architecture. Taking the existing infrastructure and migrating to the cloud without any changes is really a recipe for disaster in multiple ways. First of all, financial, because you're going to be utilizing servers when you don't need them, and that defeats the purpose of cost. But not just that, inherently the cloud is designed around being dynamic and chaotic. So it's either to embrace that or to ignore it and essentially run into issues. So if you embrace it, then there's numerous tools out there, and one of the most famous and probably the best is what's called the Simian Army. And what those are is built on the assumption that you have redundant servers, you have redundant data centers, you should adjust, the software should adjust for latency, it should do cleanup after itself. All of these things should be done by your applications. That is true whether it's on premises or on the cloud, but the fact is no one, very rarely is it ever checked for on premises. But on the cloud it's more important because it's much more likely that you may have a loss of a data center or a region or whatever. So to ensure that this stuff is done, you can utilize the Simian Army. For example, you have something called a say Chaos Gorilla, which is essentially takes down an entire region. You have Chaos Monkey, which takes out a data center. You have things like Latency Monkey, which injects latency into the communications, for example, between data centers, and sees and reports on whether your systems have adjusted to that. This is something that came out of Netflix. Its entire operations are running on top of Amazon. They don't have a single data center, with the exception of a couple of Oracle on-site repositories for PII data, but essentially the entire operation is running on Amazon. And they invented this to ensure that their developers didn't have a single point of failure, took account of the chaos out there. And so I suggest, read up on the Simian Army. It's a lot of good stuff in there and a lot of good tools to actually ensure that developers do what they should do. Next one is resiliency, obviously. Build the resiliency in from the ground up, and then make sure that there's a business buy-in. There's an awful lot of benefits outside of cost for the business. They need to understand that needs to be sold to the business. Okay, so with that preamble, let's just talk about cloud security. What are the major issues around cloud security? So this is a survey that was done by Netrix in 2015 and lists the main issues that people see in terms of security. At the forefront is things like loss of physical control over the data or loss of data, security and privacy concerns, and then dependency on the internet, the servers, disaster recovery, etc. And in terms of the bottom, these are some of the concerns: insider abuse, denial of service, malware, account hijacking, unauthorized access. These are some of the things we'll talk about. If you go to Amazon and ask them about what's their perception of IaaS security, this is what they're going to give you. They're going to say, we look after everything in the orange box, which is essentially what's in the hypervisor setting or the service that they provide, and everything in the blue is the responsibility of the user. So you're responsible for your data, the platform, applications, for identity and access management, all of these things. They're only responsible for the orange things. So there's an awful lot of responsibility that rests on your shoulders to make sure. They just give you the sandpit. It's your job to make sure that it's kept safe. So some of the threats out there. First one is multi-tenancy. So the way that typically, the cloud cost benefit is actually realized by implementing virtualization. The hypervisor is the way that this is implemented. Now this results in multi-tenancy. So multi-tenancy is where you have multiple people residing on the same physical server. The way this works is that typically the people that you're sharing the host with are random. You could, in theory, through this SLA, specify that you don't want to share, but the whole benefit of the cloud is to share and to randomize it, and as additional capacity is required, that you'll put into random systems. And that in of itself is a benefit, because an attacker really can't tell which server that you're going to be on, so they can't really attack you. So that's one of the benefits. However, multi-tenancy and hypervisor is a major draw for any bad actors. So there's a particular famous example of that, which is Venom. That is actually an attack on the floppy drive for Windows servers. What that was, that there was an exploit which is very old. I mean, I don't know how many of you have actually used a floppy drive in the last 10 years, but nevertheless, those drivers still exist in Windows implementations, even in Linux implementations, to this day. The fact that you've disabled the floppy drive is irrelevant. The fact is that the code still exists. That was used to escape out of the hypervisor and get into the environment to take control of the host system. So if you look at the steps, the first step was the Venom was used to actually get out of the virtual memory server, take over the hypervisor, and then from there access the additional virtual machines on the host system. Once they're on there, they're on the virtual network for the client organization, and they can attack that. Now, you say to yourself, okay, so I've compromised a single server, so what? If I have good firewalls, I should be able to get around that, and frankly, it's just a single server. Now, if this was used in combination with a distributed denial of service attack, then you can significantly, the attacker can significantly raise their ability to target a particular organization. So imagine if someone is using this exploit or similar exploit, then if they launch their distributed denial of service attack on an organization, what that does, it forces that organization to spin up additional instances to handle the capacity. If the bad actor is at the same time requesting the additional capacity, then there's a very high likelihood that they will be co-located on the additional hosts and be able to actually target the host organization with much more success. There's a number of studies that have shown that the ability is increased by 30 to 50% by coordinating with a dynamic, distributed denial of service attack. Next thing we can think of in terms of cloud security is insider threat. These are some of the distinctions as compared to on-premises computing. So insider is a person who is an employee, has a legitimate role within the organization, but who then abuses the role. And these are a couple of examples of things that have happened. One example is of a Google employee that was abusing the SaaS service, essentially going through customers' data through Google Mail. Another provider in the UK who actually was going through, again, SaaS, going through client internal financial and PII data. Insider threat is a major concern, and that's as evidenced in numerous surveys. This is mitigated through things like identity and access management, auditing, compliance, and really providing access to the minimum required functionality that the user needs. But nevertheless, this is a particular threat on the cloud because it's difficult to know who is going to be accessing your data because those people are employees of the cloud vendor. Because you really can't tell if you may be compromised or if you have been compromised through hypervisor or through some other channel, or there could be an insider threat. It's always best practices within the cloud to provide data encryption. And I would say whether it's PII data or not doesn't really matter. All data must be encrypted. Encryption means that it should be encrypted to the cloud provider and back from on-premises, which is data in transit encryption. We should have encryption of data at rest so that if anyone steals the data within the database or what's stored, that is also encrypted. One thing that everyone always forgets about is in-memory encryption, which is the data within the memory of the application as it's being executed. This is trivial to encrypt as long as the program is set up correctly. On premises, it's usually an afterthought, but for cloud, I think it's mandatory to ensure that this is done. One last thing, we've been focusing on cloud computing, but there's also cloud storage. And with cloud computing, storage is ethereal. It's essentially, depending on the cloud provider, it can be 30 to 90 days. So once you shut down a server, the virtual memory monitor file is actually kept for maybe 90 days maximum, and then it's lost. Whereas when we're talking about cloud storage, that can be kept, in perpetuity. Some of these cloud storage is kept for years. I mean, cloud services have only been around for the last 10 years, but many cloud providers actually keep this for a very long time. So if you don't need the data, whether it's encrypted or not, particularly in cloud storage, remove it. You need to have a data lifecycle to remove any data that's there that hasn't been used anymore and no longer necessary because it may be compromised eventually. Okay. Next one, if you've turned around and encrypted the data, that necessitates that you're going to have key management, the encryption keys. So if you do have key management, then you have to have best practices around key management, which is you need to ensure that have secure generation of keys, that the keys are available when needed, particularly if you have redundant sites, etc., that the people who have access to those keys, that there's dual control with a strong separation of duties, and that mitigates the threat of insiders. And then you need to have good controls around key management to ensure that you know who has access to it, what they've done with it, and not just that, you have a full life cycle for the keys. You need to have a plan to rotate, refresh, and retain and destroy keys. You have to know where your keys are. Where's the repository? Who has access to them? You have to know what the quality of the keys is. Where do they come from? Did someone inject keys that you're not really sure of? Don't reuse the keys. That's a cardinal mistake, because if you do, then it'd be very difficult to destroy keys and manage them appropriately. And this is just, essentially best practices around the keys. Last thing is never allow anyone to have full plain text or private or secret key. Don't forget, if you have cloud storage and it's on the cloud and someone has the key, they can go home and pull that data. Particularly, unless it's appropriately set up, but typically they can pull the data from home. On premises, you can control who has access to the data. It's not like they're going to walk into the data center and pull the data. On the cloud, it's much more likely they're going to be able to pull that data if they have the key. So it's critical that you manage the keys appropriately. So when you manage the keys, then the next thing is, how do you control the people who manage those keys? Now, first thing, let's talk about identity management, and let's look at it from a cloud provider's point of view. From a cloud provider's point of view, when you talk about user or identity management, the cloud provider's perception is you're talking about the people who can actually have access to the console, who can manage what happens there, which is, I think, an important part of it, but frankly it's just a small part of it. Really, it's much more, identity management is a much bigger topic. But let's talk about the cloud provider's view. Now, when you get onto the cloud, you will get a console, a login. In addition to that, when you set up elastic computing through the APIs and you set up keys, those keys need to be very carefully monitored. There's been numerous instances where developers who wanted to share end up sharing their keys. They upload their code in order to show others what they've done, and there's been bots written to essentially go out there and strip and find Amazon keys to that people can abuse. What that results in is your small bill from Amazon can explode. As an example of something that's gone up to $50,000. If you don't manage those keys very well. Code spaces is actually a very useful life lesson. This is an interesting one. So Code Spaces was a SaaS provider that used Amazon Web Services. They didn't really manage their keys or their access very well. Their access was compromised. They didn't know that. What ended up happening was that a denial or distributed denial of service attack was launched against them. Immediately, Amazon tried to shut it down because they've got very good systems in place to shut down DDoS. But what they discovered was that the DDoS attack was emanating from their own servers. So they contacted CodeSpace and said, oh, we can't shut this down because it's coming from your own servers. So essentially, CodeSpaces was paying for their own DDoS attack against them. So they logged on and they found that on the console was a ransom note saying, give us a bunch of Bitcoins or we will shut down your entire company. Now, contact Amazon, they changed the access, they went to a backup, but the bad actors were actually in front of them and they mitigated that, so they couldn't do that. So the net result was they lost their backups, because they didn't have any, but not just that, they were down for so long that the company ended up folding. This is probably the worst situation you can be in, where you're actually funding the bad actors to attack you, and the net result is that the company goes out of business. So in terms of time check, we've got 12:49, and I want to leave a few minutes for questions. But the next thing I want to talk about is identity and access management, which is great. So we have a choice. We can set up the cloud to be its own separate trust environment, or we can extend the trust environment from the on-premises over to the cloud. The benefit of doing the latter is that you can extend the compliance and the processes you have in place, particularly around security, identity management, and mitigation of insider threat and privileged access to the cloud. In order to do that, you need to extend identity and access management to the cloud. In order to do that, you need to federate the IDs. So essentially, the identities of the people that you have on premises can be federated to the cloud so that the same authentication, authorization, and credentials are federated over to the cloud. So in terms of identity and access management, there's a number of components that we should be talking about. The first one is single sign-on, which is essentially on premises or on the cloud, but since it's federated, you'll have the same authorization against it. Compliance controls, whether it's on premises or on the cloud, need to be consistent. Now, in the cloud, to some extent you're reliant on the cloud provider to help you there. There are a number of services in place to do this, but frankly, they're reasonably immature, so it makes a lot more sense to extend what's on premises over to the cloud. Password management. Role management is an interesting one. Role management is categorization of user access based on what their jobs are. That can be extended from on-premises over to the cloud, or that can be derived. There's a number of companies out there who look at, for example, within Microsoft Azure, who extend the AD domains over to the cloud. They look at what AD groups you belong to, derive the role based on that, and then provide access and role management on that. And then you have identity analytics to provide reporting on who has access to what, data governance, which is the life cycle around the data, and then access requests. I mean, what is the process of requesting and granting access that's on premises and extended over to the cloud? So if you extend identity and access management, and essentially the governance, risk management, and compliance over to the cloud, you have a number of tools which are reasonably mature over to the cloud, and then utilize other tools within the cloud to augment those. So that would be cloud audit. You can augment them with other less mature services on the cloud, things like identity as a service, which I think it handles the identity management on the cloud, but is frankly very immature. You have security as a service, SecAS, which is frankly a rudimentary implementation of security, which is really around malware, email, over to the cloud. So homegrown cloud services, to some extent they're immature. It makes far more sense to extend what you have on premises over to the cloud through federation and implement things like privileged and identity management on the cloud as an extension of what you have on site. Now, this is built as an introductory deck on identity and access management and security, but if you look at the appendix, you'll see that I've thrown in a number of things in here. So in terms of identity federation, there's a number of standards available, and these are some of the methodologies that people have used to extend the identity and security management over to the cloud. In addition to that, when you're talking about governance and compliance, there's a number of standards out there which I've listed here. And in terms of how security should be implemented in the cloud, I just don't have time to go through some of these details, but the PCI-DSS, which is a payment card industry standard, is a very good step-by-step method of reviewing and implementing security in the cloud. So with that, I just wanted to open up for questions. I think the first one I have is, how do we comprehend the key management? In layman language, can you elaborate what it is? So when you encrypt data, you will have keys for that encryption. Those keys are generated through an internal process provider. Those keys will be used to encrypt the data that you have, and they're required to decrypt the data as well. Without those keys, you cannot decrypt the data. So you have to keep those keys very safe if you want to actually look at the data. And anybody who wants to look at the data will have to have access to those keys. So hopefully that makes sense. Next question we had was, when we talk about the security in the cloud, then what is the rule of thumb for selecting any cloud that has the best security mechanism? I think the question as it stands would be, is there one cloud better than the other in terms of security mechanism? I think with IaaS, with the infrastructure as a service, you have the most flexibility, and you have the ability to extend what you currently have in terms of the intrusion detection from on-premises, federation, extend what you currently use over to the cloud. If you're using PaaS or SaaS in particular, you are completely at the mercy of the CSA, the CSP, the cloud service provider. In that case, you have to make sure that the SLA is written to give you full transparency into the data. In addition, you have to ensure that the PII, the privileged and data that's subject to privacy concerns, is carefully segregated and also is encrypted. And the other thing to note that a lot of the times it's very, you can add data to the cloud, particularly for SaaS. Getting the data back is a much more difficult way of doing it. If you think about it, it's like SaaS. You spend an inordinate amount of time putting the data into the cloud. It goes into relational databases. You don't know how it's structured, how it's put up. If you wanted to change SaaS vendors, it's very, very difficult. So that's something to consider. But in terms of the best security in the cloud, to a large extent, is in of itself is still gestational and has a bit of a way to go. It makes far more sense to extend what you have on premises over to the cloud. Depending on the size of the organization and what you're trying to do, there are good solutions, but there's no magic bullet for every single thing that you're trying to do out there. In terms of other questions, is it best to keep data in-house versus moving to the cloud? If it's PII data, then you have to make sure that you manage the data appropriately, have a life cycle. I think it doesn't really matter whether it's on-site or in the cloud. I think as long as it's managed appropriately and it's encrypted, if it moves to the cloud, that's fine. If it's subject to regulatory reasons, like, for example, HIPAA or European privacy legislation, then you're restricted what you can actually put on the cloud. And it's worth noting that if it makes financial sense, then there's no reason you can't put all of your data and all of your computing into the cloud. A lot of the time people don't, because they want to maintain control. And if regulatory issues aren't a concern, and if the data is well controlled and maintained and there's no financial issues, then there's no reason why data can't be on the cloud. Next question is, what do we mean by access request? Access request meaning the ability to request authorization to do certain things, permission to do certain things. So authentication is where you prove who you are, login and password, whatever, or keys. And then authorization, which is the ability to get permission to do what you need to do, and that's access management. Access request is requesting that authorization. I think we're pretty much out of time. Thank you very much for everybody joining. I really appreciate it. I've had a lot of fun. And if you want to have a follow-up presentation on some of the stuff that I didn't have time to do, please let the organizer know. I'll be glad to do it. Thank you and have a wonderful day.
Thanks, Joe.